Somewhere in your body, right now, a signal is moving at 0.5 meter per second. That's slower than you walk, in a nerve lying right beside it. Another signal is traveling at 150 meters per second. Same body, same electricity, up to 300 times the difference in speed. And the reason isn't the nerve itself. It's what's wrapped around it. The answer is fat. Every fast nerve in your body is wrapped in a sleeve of it, layer upon layer, like insulation around a wire. It's called myelin. Strip that sleeve away, and the fast nerve becomes the slow one. Your feet stop reporting back. Your hands lose track of where they are in the dark. Keeping that sleeve intact depends on a single vitamin, a molecule your body cannot build, that no plant builds, that no animal builds. Only bacteria know the recipe. Run low on it, and the insulation on your nervous system starts to fail. Quietly, invisibly, sometimes for years, before anything hurts. This is the story of vitamin B12, and it is far stranger than the label on a supplement bottle. What vitamin B12 actually does is maintenance. It keeps the insulation on your nerves in working order, and it keeps a chemical assembly line running inside every cell you own. And it matters more than you'd guess, because running short is not rare. Depending on where you draw the line, somewhere between 1.5% and 15% of the general population is deficient. Among older adults, some estimates run as high as 43%. Most of them don't know, because the warning system for this particular failure is broken by design. And we'll get to why first. What exactly is the insulation, and why does speed depend on it? In 1871, a French anatomist named Louis-Antoine Ranvier was staring down a microscope at a nerve fiber, and he noticed something odd. The fatty sheath wasn't continuous. It was interrupted. At regular intervals, there were tiny bare gaps. Those gaps still carry his name, the nodes of Ranvier, and the proportions are ridiculous. Each node is only 2 to 3 micrometers long. The insulated stretch between two nodes can be 1 to 3 millimeters. That's a bare patch separated from the next by a gap roughly 1,000 times longer than itself. For decades, nobody knew why. Then, in 1939, the Japanese physiologist Ichiji Tasaki showed what was happening. The signal isn't crawling along the fiber, it's jumping from one node to the next, skipping everything in between. Think of an express train that doesn't slow down for the small stations. It only stops where it has to. Same track, same train, a fraction of the time. That's what myelin buys you. And it raises an obvious question. Why not just build a thicker nerve instead? Nature did try the thicker nerve. It's called a squid. A squid escapes predators by firing its whole body backwards in one convulsion, and that requires a signal to arrive everywhere at once. Its solution is the giant axon, a single nerve fiber up to 0.5 millimeter across, thick enough to see without a microscope. Now compare it to a myelinated nerve fiber in a frog. That one is 12 micrometers wide, roughly 40 times thinner. At the same temperature, both conduct at about 25 meters per second. Identical speed, but the squid's version burns around 5,000 times more energy and takes up something like 1,500 times more space. Now, scale that up. If your spinal cord ran on bare, thickened nerves instead of insulated ones, it wouldn't fit inside your spine. Estimates put it at close to 1 meter across. One textbook puts it more bluntly, as thick as a good-sized tree trunk. Insulation isn't a refinement. It's the only reason a brain like yours fits inside a skull like yours, which makes the molecule that maintains it worth a closer look. Vitamin B12 is the strangest vitamin in your body, and it starts with what's at the center of it, a single atom of cobalt. A metal, no other vitamin contains one. B12 is also the largest and most structurally complex vitamin we know of, and the only place in your entire biochemistry where a carbon atom bonds directly to a metal. Nothing in you can make it. Nothing in a cow can make it either. The cow's stomach bacteria make it, and the cow absorbs it. The recipe runs to roughly 30 enzymatic steps, and it exists only in bacteria and archaea. Shellfish carry the most, then liver, where animals stockpile it exactly as you do. After that, fish, red meat, eggs, milk, cheese. Plants carry none of it. Not spinach, not kale, no matter how green. Working out its shape took one of the great feats of 20th century science. Dorothy Hodgkin spent around 8 years firing X-rays through B12 crystals and reconstructing 181 atoms from the shadows they cast, like rebuilding a cathedral from the pattern of light on the floor. She published the structure in 1956. In 1964, it won her the Nobel Prize in Chemistry. Getting B12 out of food and into your blood takes a relay race with 4 handovers. And if any leg fails, the whole thing collapses. Stomach acid frees it from protein. A carrier molecule from your saliva picks it up. Pancreatic enzymes strip that carrier off in the small intestine. Then it binds to a glycoprotein called intrinsic factor, made by cells in your stomach lining. And only then can it be absorbed, right at the far end of the small intestine. We know this because of a genuinely unpleasant experiment. In 1929, a Harvard physician named William Castle ate 300 grams of raw beef every morning, made himself vomit an hour later, incubated what came back, and fed it through a tube to patients dying of pernicious anemia. Beef alone didn't help them. Gastric juice alone didn't help them. The combination did. He'd found intrinsic factor. 3 years earlier, George Minute and William Murphy had treated 45 of those patients by feeding them roughly half a pound of liver every single day. Before that, pernicious anemia was a death sentence. Their liver diet won the Nobel Prize in 1934, and here's the catch nobody expects. Intrinsic factor saturates at about 1.5 to 2 micrograms per dose. Swallow a 1,000 microgram tablet, and only around 1% gets through. So you'd know if you were running out. Obviously, you'd feel it, or a blood test would catch it. Both of those are wrong. Your liver holds between 2 and 5 milligrams of B12 in reserve. You need about 2.4 micrograms a day. That's a stockpile of roughly 1,000 days' supply, and you lose it slowly. Stop absorbing B12 entirely, and it can take 2 to 5 years before anything shows up. Stop eating it, and it can take 10 to 20. By the time symptoms arrive, the damage has been building for years. It has a name: subacute combined degeneration. Specific tracts in the spinal cord demyelinate the ones carrying vibration, position, and balance. Tingling in the hands and feet. Then, not knowing where your feet are without looking at them. Caught within weeks of symptoms starting, it can reverse almost completely. Left too long, it doesn't. So, a metal cord molecule built only by bacteria, absorbed through a 4-stage relay, stored for years, and required to keep your nervous system wrapped in working insulation, not an energy pill. An insulation contract. And if any of this made you feel like your body is more fragile than you'd assumed, wait until you find out how much of what you see isn't actually there. Next time, how your brain lies to you every second on purpose. If you want more of the stuff nobody taught you in school, subscribe.